Hello again, this is Chris, and in this session I want to talk to you about Meadow.Linux. So Meadow.Linux has been around in our repository for a little while now, but this is kind of a soft launch of it being ready for public use. We've got documentation finally, and it's in a pretty stable state. So exactly what is Meadow.Linux? Meadow.Linux is basically an implementation of the core stack for Linux that supports popular hardware that's available off the shelf today. So it's got the familiar core stack, and it allows you to use existing Meadow drivers like Meadow Foundation or anything that you create. It gives you faster debugging and prototyping speed because you're using hardware that is local and a little easier to deploy to. And it supports things like Raspberry Pi, the NVIDIA Jetsons, things like the Nano and the AGX. It also supports BeagleBone Black. And in fact, it supports WSL2. Meadow.Linux apps look a little bit different than they do for F7. The application definition, for example, declares both the OS that you're going to be running on and the platform being the hardware. You can see here we've got an example. Both of these are Meadow.Linux applications, so you've got the Linux generic parameter, but then it also takes in that platform, which gives you the pinouts for, say, WSL2 or Raspberry Pi. We've got more pinouts than this in the repository, but these are just examples. Another example is that the startup is different. On an F7, we've talked about this, where Mono launches into the Meadow OS for you when the device boots up. Another difference with Meadow.Linux is app startup. On the F7, Mono launches and automatically calls the Meadow OS for you. On something like a Raspberry Pi or any other thing running Linux, that does not happen. You have to manually launch it. You can see here, we've got the public static main, which we define, and inside of it, we must call Meadow OS start. We need to await this because it's an async, and this will in turn launch our initialize and our start in our application class. One of the interesting things that Meadow.Linux brings is the GTK display. The GTK display is an implementation of iGraphics display, which all of our other SPI displays and things like that implement. So what this means is you can prototype things that you do in micrographics using WSL and GTK using this type of display. You can see here the code shows that we have defined a display and a micrographics. Basically, we just create the GTK display just like we do with any other, and then we pass it into micrographics. You can then use micrographics to affect your UI and build it however you want. The nice thing here is this allows you to run it on your desktop in GTK without having to deploy it down to the device, so you can iterate a bit faster. So let's go take a look at what this looks like in code and at runtime. So let's take a look at a simple GTK example. Over here we've got our application. I just called it Cube App, but it derives from app. It's going to run on Linux with the platform being WSL2. Here's that entry point that we talked about where you have to declare a main and call Meadow OS start. Meadow OS will in turn call initialize for us. This is where we create our GTK display and pass that into micrographics. And Meadow OS also calls run. In run, we just call this show 3D cube, which has an infinite loop here, which draws a rotated cube. So let's go over to a console and run this on our desktop. And now if we run the application over in WSL, you can see that gets us our spinning cube. So basically we've created a simulated display running in GTK right here on our desktop. Same thing would work also on a Raspberry Pi or some other Linux device. Meadow.Linux is also useful for things beyond just prototyping. You can use it to build HMIs that actually talk directly to hardware. You can use things like Avalonia for your UI gives you full MVVM. It's familiar. It's cross-platform. You can then use in it the Meadow core stack to access hardware. And because you're using the Meadow core stack, you have access to all of the Meadow Foundation drivers. So let's go take a quick look at a demo of that. This sample app is a bit more complex simply because it's got a little bit more going on. Rather than deriving from app or from the Avalonia application, we have to derive from something that is a composite of the two. Avalonia wants you to derive from their application, whereas Meadow wants you to derive from app. But otherwise, this looks very similar to an Avalonia app. If you're coming from Xamarin or WPF or Maui, this will all look very, very similar to you. We're basically creating the main window and a view model, loading up the Avalonia stuff, and then we also load the Meadow OS. And then we have an initialize. One of the other challenges is that Avalonia has an initialize and Meadow has it. So we have to effectively shim from one to the other. So this initialize Meadow is the initialize call from the Meadow application. Down in here, this is where we derive from the application for Avalonia and implement the iApp for Meadow. And then we've got some implementation pieces here. Most of them don't have to do anything. They simply return a completed task. The important thing here is that Meadow OS gets started in a background thread. So there is a background thread that we start up at the beginning of the application, and then that thread just runs the entire life of the application. So the view here is pretty simple. We just have text with a button. Didn't go anything complex because we're really just trying to look at how these things are tied together. The important thing here is if you look at the button, we have a binding to an LED command, and that is back in the view model. So if we go take a look at that, we have a reactive command called LED command, and that basically is just tied to toggle LED, which turns the state of the LED on or off. And the LED comes from the Meadow resolver. It's an iDigital output port. So all we're doing is using the same digital output ports that we've been using on the F7 and anything else to drive an output. In our case, we are using a Raspberry Pi, and this digital output is on pin 40 of the Raspberry Pi. So when we click the button, it turns on or off, basically inverts the state of pin 40 on the Raspberry Pi. I have that tied to an LED on a breadboard, and then that drives that high and low. So let's go take a look at that in action on the device. So here we have our Avalonia app running. The connector for the Raspberry Pi is on the side on this re-terminal. We've got pin 40 comes over to one leg of the LED, and the ground comes over to the other leg. So if we click the button, which then calls into the view model, changes the state of the LED, and it becomes true, so it turns on, and we can click it again and it turns off. So we have very, very simple hardware integration with a cross-platform UI for a human-machine interface. So there are a few very good, compelling use cases for Meadow.Linux. I'm sure there are others that people will come up with, and it'll unlock a lot of additional use cases. Looking forward to seeing what other people do with it. If you have any questions right now, though, by all means, put them into your streaming service that you're using for watching this, and we'll do our best to answer your questions. Thank you for watching.